Thanks a lot. Hi, everybody. Hey, my name's Jeff Williams, and today I'm going to be talking about doing application security at DevOps Speed and portfolio scale. But first, I'd like to start with a little announcement. I think this is cool. Just this weekend, the XSS prevention cheat sheet I wrote went over 1 million page views, which I think is kind of cool. And yeah, right. It's all for me. So check it out. Drive that number up. I'm psyched about that. And so how many here have used the XSS prevention cheat sheet? There's a bunch of people. That's cool. How about the WebGoat? Cool. Enterprise Security API? Any developers in the room? Awesome. OWASP Top 10? Okay, here's a tough one. Who's used the OWASP Secure Software Contract Annex? Ooh, all right, you don't count. So go check it out. So I wrote all of those. And I feel like I should be really proud about that. You can see some of the numbers of those, like those are some of the most popular OWASP pages, and I feel like I should be really excited about that, but I'm really not, because I don't think that stuff is actually working very well. So I'm getting ahead of myself a little bit, so let me jump back a little bit and introduce myself. I'm the CEO of AppSec Security, consulting company. If you're really good at AppSec, I've got some great jobs available, so hit me up. That's awesome. I spent 8 years as the chair of OWASP. I was one of the OWASP founders, and so I'm really passionate about what we're doing in our mission. And I spent the last, since I retired 2012 as the chair of OWASP, I spent the last few years working on a new product, a new way of doing application security called Contrast, and we're demoing it in the other room. So come on by the booth and check it out. I'm really excited about it. If you're fed up with static analysis, then definitely come by, because it's definitely different. All right, so I want to start by making an analogy to healthcare. And I want you to imagine that all those applications out there are sick patients. And we've got a lot of stuff to help them. We've got doctors, people that specialize in application security and really smart at it. We got some super powerful tools like X-ray machines and MRI machines and so on that require experts to run them. But and the doctors are doing a good job, right? We're helping people. I've helped a lot of people over the years, but even if we had 10 times the number of doctors that we have currently, we're not going to make a dent in application security in general, because we're not doing anything to really stamp out the disease. We're helping individual patients with their symptoms. But I really feel like we're not making progress against things like SQL injection and cross-site scripting and CSRF and all the others. I think we need to think a little bit more like the World Health Organization and public health in general, to use some different techniques. We need techniques that are going to scale massively. So, the World Health Organization, I just did a little blog post about this. They're monitoring everything about the flu epidemics worldwide. They've got all kinds of sensor networks, and they're doing even crazy stuff like monitoring Google searches and really interesting stuff. They're gathering huge amounts of data and making interesting progress against the disease. And we need techniques like that will scale. We can't just keep doing, individual doctor-patient kinds of activities if we want to make progress. Again, it's the big fight here. So I think we need to adopt some of those techniques that'll scale. That's some of what I'm going to talk about in this talk today. We can't just scale up. By the way, we can't just scale up the things that we're doing now. Like, we can't just say, well, let's just do code review. Everyone agrees code review is pretty good practice, but we can't just say everyone do code review on all the code out there, because it'll never work. So I'm fascinated by what's going on in healthcare. There's this sensor revolution going on. Anybody wear like a Fitbit or have some other live sensor that's tracking your vitals? It's fascinating, right? I feel like that technology is going to continue to improve, and pretty soon you're going to have continuous real-time monitoring of all the stuff in your body. That's fascinating. Like right now, if you want to get that stuff checked, you got to go to a doctor and get a checkup. Like, who's been to a doctor in the last 6 months? It's not everybody, right? Like, I don't go to a regular checkup. I should. I'm getting older, but I don't do it, right? And I feel like it's a really reactive way of doing healthcare, right? Like, I wait until I get super sick, or injured before I go to the doctor. And I feel like that's a lot of the way people practice AppSec, right? You wait till you get hacked or breached, and then you're like, oh crap, we need the specialist to come in here and help us get healthy. That's not wellness, right? That's not healthy behavior. So I'm down on this this periodic checkup thing. I'm trying to think about how can we do this continuously and in real time. And I've been looking at some of these, these startups that are building these things. They're building these amazing sensors for everything, like heart rate, and they've got a sensor. It's like the size of a grain of rice. You inject it in your arm, and it monitors your blood sugar. So now diabetics don't, they don't have to go into a sugar coma or whatever to, before they get help. They can find out. And they said in a few years, your phone's going to know that you're sick before you do, because it'll know, right? It'll have all the data. So I think this is really a powerful analogy. So I'm thinking, you might be thinking, hey, we got a lot of tools, Jeff. The tools are pretty good. Like I'm getting some data and I'm on top of it. Well, I'm looking at these trends in software development. There's probably a dozen more trends in software development that are equally difficult. Our modern tools and techniques don't really deal with any of these. Like you can't do static analysis very well on applications that use inversion of control and a lot of frameworks and a ton of libraries. The static analysis tools don't scale very well to them. And you can't really scan applications that use different service interfaces. Now, our scanners only support HTTP pretty much. If you're even doing like SOAP and REST applications, it's difficult to get good scan results from them. And if you move on to like serialized objects, like anybody ever intercepted some GWT traffic? Looked at it, it's like a complicated serialized object. You can't just change parts of it because it'll wreck it. And we need tools that understand all those protocols. But now we're moving to raw socket and WebSocket connections where people are writing their own protocols and their own data structures to send over those protocols, and we don't have the tools to scan them. So you may have noticed now when you're doing pen tests, it's taken a zillion times longer to do them because you got to spend most of the whole engagement just getting your tools to intercept the traffic and try and work with it. So we got a lot of blind spots, and I really worry we don't have tools and techniques to deal with modern software development. In fact, I've said that modern software development is pretty much incompatible with the way that we do application security today. All right, so to try to sum it up, I'm gonna use this slide. So here's security. This is an XKCD picture, right? And we're climbing up this hill, and I feel like we've been climbing up this hill at OWASP, and we've been making good progress, right? We've put out some standards and guidelines and some tools, and that's all been going pretty well. The problem is, at the same time, software has been moving ahead way more rapidly, right? And so we feel really proud, like, yeah, we made it up to here, but we're climbing this separate hill, which is a problem, and we're not going nearly as fast as software. So it's rocketing ahead. I believe we need to move our activities over into software development, really become part of software development, not just, most people talk about this, we got to work with developers. But really what they mean is take what we're currently doing and they'll say push left, right? Shove those activities earlier in the life cycle. But they're not talking about changing the activities, right? They're just saying like, well, we should do security architecture review, and we'll do that early in the life cycle. But they're not actually talking about integrating into the software development process, right? Working side by side with developers, actually having the developers just do them themselves. This is the goal. For me, this is what I'm calling continuous AppSec. And let me define what I'm talking about there. First thing is I think we need to start over. I think Michael Coates hit on this morning. He said he's not interested in anything that doesn't scale. And I'm totally with him because I've worked with so many software development organizations that, for them, the security group is a roadblock. It's just, they're writing code and they're moving out, and then they have to wait for the security team. They get results that aren't really that useful to them. And so it's just, it's incompatible. So I think, this is a scene from Apollo 13, right, where he says, our oxygen scrubbers aren't working anymore. We've got to make this square peg fit in the round hole. And we got to do it with the stuff on this table. So I want to think about, we got a lot of cool stuff, right? We've got scanners, we got static analysis tools, we got a bunch of techniques and processes like code review and architecture review and threat modeling and so on. But I think we need to reimagine them in a way that's compatible with modern software development. And I'm going to talk about my ideas there. Yeah.
So, I brought this up to your help because just like you said, right? Somebody writes the code and then somebody reviews the code after it's being done written, right? You never get it at the point of inception. And the argument, and I'm going to ask this question, the argument was, we just don't have enough security resources to scale at the developer front end, right? At the actual growth. So do you think tools need to take the place of active security developers that integrate with these teams in the DevOps model? Is that where you think it's going? Because of the scale.
So yes, I do. But let me build out the argument for how I think it can actually work. I mean, ultimately, and here's the cheat forward is, I think what we need to do is take the knowledge that security experts have and automate it, right? And it's sort of a Dennis Cruz style line, but I think that's really what needs to happen is we need to do everything we can to automate the knowledge that we have so that it can scale. And I'll talk about how I think that can work. All right, so what I mean by portfolio scale, and I work with organizations that have hundreds of apps, some of them have thousands of apps, some of them even have more than 10,000 apps. Think about that, 10,000 applications. Think about if you're going to take, I don't know, say a really fast review would be like a week, right? Well, if you want to do all your apps every year, that's just a colossal amount of work, tens of millions of dollars worth of work, no matter how you slice it. And they just can't afford it. They got to do something differently. So for portfolio scale, I want to define like the goal. Like what is our actual mission in application security so that we can focus on it and just get it done. There's a lot of, there's these models that you can download that have like 150 activities in them. And, the goal is not to do all those activities, right? The goal is to actually produce security of some sort. So I want to define that. I want to say for these applications, you have the right defenses, and that those defenses they're present in the application, they're correct, and I'll talk about what that means, and they're used properly. If you have that, you've got the basics of an assurance argument for your application. So that should be the goal, right? If I can produce this, then I'm done. So I want to get busy to work at producing this as quickly and as efficiently as possible. And I want to do it at at DevOps speed. Right? And by that I mean that it happens continuously and in real time. And this is really just an acknowledgement of the way that software is built now. If you're doing, monthly or weekly or daily sprints and builds and pushes to production, you can't have security results that are a month behind or a year behind. I mean, the way that, most organizations are doing their AppSec programs is they've got like an annual schedule for reviews, and they're really only looking at the critical apps. But a year is way too late. By then the software's moved on a million miles. So you may hear a lot of people talking about DevOps and Agile as being antithetical to security. I don't think that's right. I think Agile and DevOps are really good ways of building things. And what we need to do is transform what we do in application security to be themselves agile. And it takes a little bit of rethinking, but I got an idea about it. So we're going to need to automate some stuff. I want to show a path towards making what we currently do into something compatible with Agile and DevOps software. So let's look at one thing at a time. And to me, fundamentally, this is what Agile and DevOps are all about, right? They focus in on a single sprint or a single feature, and they build it all the way from soup to nuts, test it, and deliver it. We can do the same thing with security. So that's the announcement. I want to Agilify application security. So let's just look at clickjacking. That's just one thing. But imagine, for you, that's what your security policy is. You actually get to decide what you care about for security, right? You can decide it's the OWASP top 10, or you can decide it's whatever your scanner tool looks for. I just want to decide, for me, it's about clickjacking. So let's look at how we can do that in an agile way. So before we talk about that, I wanted to give you a little background on how you can, the theory behind how you can build assurance in some security control. So this is a typical application stack. You can see you got a controller layer, some business functions, data layer, comes back out the presentation layer, and it's built on a big stack of software, right? Libraries, frameworks, app server, runtime, OS. Now there's a lot of places in this where you can gather data that's relevant to proving whether we're doing clickjacking protection right. So what do we do to protect against clickjacking, by the way?
Extreme options coverage, that radio JavaScript frame custom techniques.
So you got a couple things you can check, right? So let's look at how that rolls out. So this thing's so bright you can't really see it. Underneath that picture is that blue stack thing. So I think of a vulnerability as like a path through that big stack. Okay? So the vulnerability, it's not just one line of code. You see tools that often say well, the vulnerability is right there. But really it's not. There's a path through the code, and if there's a defense any place along this path, then you don't have a vulnerability. So it's important to really understand what's going on through the whole app. And there's these places in the code, like the HTTP traffic, you could look at that. That's actually not a bad place to talk about clickjacking. We'll get there in a second. But you could look inside the code. You could look at the data flow or the control flow. You could look at the libraries and frameworks that are being invoked. You could look at the configuration data, or you could even look at the backend connections. And these are the sources where you can get data that proves you're doing clickjacking protection correctly. So I want to pick what the best one is, right? Like which ones of these should we get the data to prove clickjacking for our little application, right? So I built this little table to help design what I call a sensor. So we'll build in real time, let's build a clickjacking sensor that verifies for this particular application that we've got the right clickjacking protection in place. So we can look at all these sources of intel. For me, HTTP makes the most sense, right? So I think we can gather HTTP data to show that XFrame options header is there. And if you want, you can scan the HTML to see if there's a JavaScript frame breaking script in place too, if you want sort of defense in depth. And for analysis technique, there's a bunch of different types, right? You've got manual testing, static analysis, dynamic analysis, IAST, which if you haven't looked at interactive application security testing, it's very cool. We're doing some demos at our booth, by the way. I think passive here is we can verify this passively for our application. So we'll talk about how we do that. And then the experiment style is really important. Most tools use a negative test. They're searching for a bad pattern in the code or the output. I'm really a huge advocate of verifying a positive pattern in the code. So think about taking your secure coding guidelines and automating them, right? You've got a rule that says every page should have an XFrame options header on it. Okay, cool. That's a positive rule that we can verify, and it's actually way simpler than trying to search the whole applications for every possible way that you could screw up. You can do sampling. There's other things you can do. And then we need to choose an environment. Like, where are we going to deploy this test? So across the life cycle, where do you think is a good place to put our sensor to verify that we've got XFrame options protection in place? Like, where's going to be the easiest? And I mean, look at the factors, right? Where's going to give us the fastest feedback for developers, the most accuracy, the best feedback for developers, like in terms of richness, like how much details does it have? Where is it going to scale best, ease of use, and cost? Dev, CI, both good choices. It actually depends on your organization, and I don't care. Like, maybe you've got a great QA environment where you can deploy this sensor easily. Maybe you can put it right in your dev environment if you've got some tool that you run, maybe a Selenium test suite that you could attach a sensor to. Awesome. So I chose a test environment because that's where it's easiest for me. And then think about these factors. When you're building these sensors, you can choose to make it the easiest as possible for your organization. So what we're really doing is we're taking an organization that looks like this, and under all those little balloons is the security group, right? They're currently doing all those tests on an annual kind of basis. And what we're trying to do is we're going to take one of those for clickjacking, we'll move it out, and we'll make it real time. And notice what happened is this group went to a PDF file. Now we've got a real-time sensor producing data every day about whether all our clickjacking protections are in place, right? There's no extra real cost. Once we build the sensor and deploy it, then it's basically free. We're getting that data all the time. We do need some sort of collection. I'm going to call that a data warehouse, or security intelligence data warehouse, right? And we'll just gather data from these sensors and bring it into our warehouse. Now, once you do that, you can start to imagine deploying these sensors out in lots of different applications. Maybe your internal networks, you got ad hoc servers out there, external facing servers, even servers deployed in the cloud. Gather data from your entire infrastructure and start bringing it into your warehouse. And so, this approach is real flexible because it doesn't matter what your technical architecture is. It doesn't matter what your development processes are or your organization structure. The key is gathering great data directly from your applications that you can then use. So, all right, we can deploy these sensors. And then, so here's imagine this is your application portfolio, and we deploy this sensor on a bunch of those applications. They start producing data, feeding into our warehouse, and now we can talk about the reporting side. We can get these great reports that show, here's our application portfolio. We've got scores for clickjacking for each app, and you can even imagine drilling down into one of these, like the financials app here, drilling down into this and saying, hey, here's exactly which URLs need clickjacking protection and which ones already have it and you're fine with. So we're getting a long way here towards my goal of scalable, real-time, continuous application security monitoring. And you might be thinking, hey, this is just clickjacking. Where are we going with this? So I want you to get, really start to think about how this scales out. Now, I did, on a business trip recently, I wrote a little tool. You guys remember the Beastie Boys Check Your Head album? All right, so I wrote a little app called Check Your Headers. And you can go online. This is on Heroku. And just put in any website you want. And it'll issue HTTP requests on the back end. It's a lot like SSL Labs. But run it on a website and see what their headers are. I've been looking at a whole bunch of different websites, and it's fascinating what people are actually doing. Your question?
Yeah, I wrote securityheaders.com.
Oh, yeah, nice.
Same exact deal.
Excellent, excellent. Yeah, so this is to help demonstrate, the power of real-time security verification. Is you can run this on your application anytime, pull down great data. I actually packaged this thing up into a script that scans a whole bunch of internet companies and then a whole bunch of financial organizations, and a number of these are my clients, so I sort of crossed them out. But one thing that I find is weird is in the old days it used to always be the financial organizations that were leading the way with security, right? They've been pushing pretty hard. They do a good job at a lot of this, but for some reason, with the new security headers that have come out in the past 3-4 years, the financials aren't adopting them. Like I look at all these different organizations, and only a couple of them have X-frame options. Almost none of them have strict transport, and matter of fact, none of them do. And you go across the list, and they have some caching, and they set their content type okay. That's not really taking advantage of the headers we got today. If you look at organizations like Twitter and Etsy in particular, Gmail, they're doing a lot with these security headers. You think they're kidding around with their security? I don't understand, it's sort of an anomaly, but you can get some real interesting visibility. Now imagine, like, instead of doing like a whole bunch of websites, imagine you're running this on your internal applications, right? Every day, continuously, dashboard with all your clickjacking protections across, all your headers across your whole enterprise. And you can start to see, like, hey, wait a minute. That means my pen testers have, like, a few less things that they have to do every time. And the more you automate, the less your pen testers have to do manually each time. And so I think that's the goal, is eventually just stamp out that job entirely, right? Instead of having your pen testers do the same stupid tests over and over again, let's automate the ones that we can eliminate, and let the pen testers focus on the things that are truly unique and hard. And hopefully the output from their work is not another PDF report, but a test case or a sensor that you can then deploy so that if they find a flaw, you'll never have that problem again, ever. That's the improvement cycle that I want to get to with this. But I got a little bit more. So here we go. We transform clickjacking to DevOps Speed, portfolio scale, and it's really pretty easy. Before we had an annual pen test, now we're continuous monitoring. Before we had negative signatures, now we got a positive verification. And before we were doing one app at a time, now we're doing it portfolio wide. And so hopefully the business case is starting to shine through here for this. This is, work once and apply it forever. But it's just clickjacking, so big deal, right? Like, let's talk about some of the other things that you might do. So you can use the sensor approach to verify just about everything in application security. Maybe everything, actually. For instance, maybe you want to verify that your business logic makes access control checks. Maybe you want to verify that your libraries are free from known vulnerabilities. This is the new A9 in the new OS Top 10. Pretty important. You want to verify that your forms don't have CSRF attacks in them, or that your interpreters have protection against injection. These are all pretty important things, and they're not terrifically difficult to automate with this sensor-style approach. This one I'm huge on is make sure your encryption is implemented correctly, or that your application doesn't make unknown connections, or a whole bunch of other stuff. So let me go through a few examples of some of these to show you, just some ideas on how you could build sensors to do this stuff. So here's an access control sensor example. So this is on an application that we run internally at Aspect, and it's a pretty big application, and it's got a whole bunch of access control checks. So I thought, hey, you know what? We should have a sensor that's monitoring those to make sure anytime we check in new code, anytime we change anything, that the access control checks get done correctly. So I wrote a little tool to search through and find out, in our app, we're using pre-authorized annotations to do it. So we search through, pull out the pre-authorization annotations statically, and then we analyze all that to see if it's got the right check. So we get all this data, and we can look quickly and see like, oh, look, the status controller and the error controller and the login controller don't have access control checks. And then we have to think, like, is that correct? It turns out those are fine, right? Those ones don't need access control because they're basically public functions. But this was great, right? We got a great check. How long would this have taken to verify with a pen test? Like a week, right? Like
$30,000-$40,000.
That's right. How long would how would it get verified with a dynamic scanner? Not at all, because scanners don't verify access control because they don't know what the model should look like, right? And how long would it take to verify with static analysis? Well, just onboarding the app will take that long. But I think it will be difficult. There's no way to really teach the static analysis tool to do this for you. And so there's an opportunity here to build something. And it doesn't take long. I built this in half an hour. And Rand, I did this talk at the OWASP USA conference, and I just wrote it because I thought I needed another example. I also did a little transformation of that data into an access control matrix, right? So you pull the data out of your app, transform it into an access control matrix, and then look how easy it is to see, hey, here's your access control model graphically, and you could freeze this and say, look, this is the model. If anything changes, alert me. Now you've got some really powerful security analysis, real time, basically no cost to running this stuff. And you get access control checking. Where does access control fall in the sort of the hierarchy of important things in AppSec?
Top of the list.
Yeah, authentication might be top of the list just because of the prevalence of authentication problems, at least in my experience. But access control is right there. When you look at number of problems times criticality of problem, it's access control. And so, this is really important stuff, and it's basically not getting tested. Most apps have never had their access control checked, ever. But we got to do a better job at that. All right, so that's one. How about a known vulnerable library sensor? Well, hey, good news. There's OWASP dependency check, written by Jeremy Long, great OWASP contributor, great guy. He put together a little tool that you point at a directory, It runs and it produces a great report of what libraries you got and which ones have known vulnerabilities in them. It's pretty useful information to give back to developers because there's some pretty serious vulnerabilities coming out in some of these libraries. So this is a simple thing to add to. Where would the best place in the life cycle be to add this check? Yeah, it could be in dev, it could be in your CI environments, like it'd be a nice place to just check it in one place. A lot of opportunities here to deploy this, but we don't need to have vulnerable libraries, and it is staggering. I'm fortunately in my business I get to look at hundreds of applications every month, and the number of known vulnerable libraries being used in production applications is absolutely staggering. It's 4 or 5 libraries per app in most cases. So let's talk about CSRF. This is a little interesting one. So to verify CSRF, you got to make sure that there's a token generated in every one of your forms or state changing requests. And then you got to make sure that that token actually gets verified when the request comes into the application. So that's what we want to verify. Cool thing, I talked to Simon Bennett, who's doing Zap, and they've got a pretty cool way of testing this with the new Zest scripting languages built into Zap. So you can create a little script that verifies the token, and then Zap will actually modify it or remove it and run that same test again, and hopefully that request should fail, right? So it's a very short little test script and very powerful. And then you can even pull the results out of Zap with a REST API directly to Zap proxy, right? So now you've got this basically passive way of verifying this. You could put this in your test environment. Maybe when you run your integration tests, you generate a lot of coverage over your application. You could actually pretty easily prove that all your state changing forms have CSRF protection and that it's working. Well, there's another thing your pen testers don't have to do anymore that's kind of time consuming, right? So we're slowly converting everything over to continuous real-time protection. Let's keep going. This is, remember I said correctness is really important, and I started my security career back in the Orange Book days. I worked with some of the guys who wrote the Orange Book, and for them, correctness was everything. They really believed in having a formal model and traceability through the whole design down to a formally tested, formally verified implementation. And we're not going to get there because it's a lot of work, but I see a lot of organizations that have security mechanisms that they don't test at all. Like they definitely have a security mechanism that they use, but they don't test it. So for instance, one organization, I went in to look at their input validation and escaping methods, and I found over 30 different HTML entity escaping methods in their code base. 30 different ones, and all of them were wrong. All of them. They were not encoding the characters correctly. We need to have one implementation that's really strong. And so that was sort of the genesis of the ASAPI project. And one thing we did right with the ASAPI project is we wrote a ton of test cases to verify that those controls actually do what they say they're doing. So this is this is some test code from the canonicalization method, and you can see we tested a zillion different ways. There's all these different nested and partial encoding examples, and we verify that the canonicalizer properly canonicalizes all of them. So there's thousands of test cases there to verify that those controls work. That's great protection, and it saved our bacon when we were making ASAPI because some change somewhere else in some of the code somewhere could affect this and cause these test cases to start failing, and we would never have noticed it, except that the test cases were there. So I think this is really important to make sure that your controls are correct. And remember, at the beginning, I said the whole thing that we want to prove for all these apps is that the controls are present, that they're correct, and that they're used properly everywhere, right? So correct is a pretty important part of that. Here's an example of looking at injection, and I've been convinced over the last couple years that the right way to find injection is by doing data flow analysis, and I think the best way to do data flow analysis is not statically, but at runtime with instrumentation. There are some tools coming out on the market that do this. It's a reliable way of doing data flow analysis. Here you can see a cookie come in, gets translated into a base64 byte array out of the base64 encoding, and then you can see it slowly build up a SQL query. Very accurate way of doing data flow analysis. And you can deploy this in dev, you can employ it in a test environment, you can employ it even in prod, potentially. So, I could go on with a whole ton of different examples, but I think you start to get the process here, is that for what you care about, you can make sensors to protect yourself, to verify continuously and in real time what you're trying to prove about your application portfolio. This is a very different way of doing application security than just sort of going through life cycle stages, like, well, what do we do for security requirements, and what do we do for security architecture, and what do we do for security implementation and test, and so on. I think of that as really very not agile. It's waterfall style security, which is still what most people are practicing. Even on agile projects, we try to shove that square peg into that round hole and make it work. So there's a lot of different things that you can gather this way. So ultimately, if we do this, we may be able to deploy sensors out across the organization and pull really great information into this data warehouse. Now imagine that you're a developer, and instead of having to wait a year for your report, now you've got live, real-time security information available to you while you're coding. It's a lot different. And it's easy to manage, actually. You can just work it like your normal issues. When a SQL injection pops up, you fix it, go back to work. You can even fix these problems before the code gets checked into CI. But it leaves us with a huge question. Okay, that's great, Jeff. We can build sensors all day, but what sensors? Who chooses? This is something that most organizations aren't really wrestling with, right? How do you guys choose what things you're going to verify in your reviews? That would be great if people actually did that analysis. You'd say, hey, what is the business about? How do we translate that down into security defenses and figure out what controls need to be tested? But that's not how most people do it. How do most people do it? Yeah. Yeah, they go through some list, right? Like you go through the OWASP top 10, or you go through the WASP list, or you go through, really, most people probably just do whatever the hell their tool looks for, which has nothing to do with the business requirements, right? Like it's whatever's easy for the tool. That's what our security policy is. And we should change that, right? So I think it's actually important to figure out what matters. This is the results of AppSec's work over the last year. You can see here, ours looks a little different. Most companies that do this work put out a annual report like this that has some results. AppSec does mostly manual penetration testing and code review. We don't rely on a lot of tools, and so our results are a little different, right? So here you can see identification authentication is the #1 thing. And actually, if you add session management, which is the third column, on top of this, because really it's part of the same thing, then you can really see the importance of authentication and how most of the critical problems are coming from that category. In fact, you can see the higher risk ones are this dark red color, and the lower risk ones are this more pink. So you can really see, to me, that's where a lot of organizations need to focus. Input validation comes up there. Access control is in the list. But this is one way of prioritizing what you're going to focus on. But I think I want to explore this just a little bit and talk to you about what are the sources for those requirements in most people. And I'm going to call this the expected model, right? If you were building an expected model, most people don't, but if you were, what would the sources of information be? Well, they'd come from things like security requirements and threat models and abuse cases and standards and so on. Those are a lot of different levels, and they're not usually very integrated together. Like it's not like a nice organized, complete structure. There's just these different documents that people have. They did a requirements and they did a threat model and they did these disconnected things. And so you end up with this weird kind of spotty coverage in people's thinking about security, the things that they have to have. So, for example, I've seen people, well, let me do that in just a second. So the other side of it is, what are you actually verifying, right? So that was the expected model. Now this is the results of what you're actually looking at, and it's similar, right? You've got different activities not very well integrated together. You might check for the same thing in a pen test that you check for in a code review that your scanner's looking for, so there's some waste there, and you end up with this pretty spotty picture of what's actually being verified. So I want you to sort of put that together now and think about what happens when we overlap these things, right? You've got your expected model and your actual model, and they're not perfectly aligned. So you end up with some stuff over here that's not being tested, like access control that I mentioned before, right? That's just pure waste. I'm sorry, that's just pure risk, right? If you've got, if you don't know whether your access control is implemented properly, that's a risk. And then on the other side, there's stuff that people are testing that doesn't need to be tested because it's not part of what you expect to be there. And I've seen tools testing for SQL injection on applications that don't have a SQL database. I've seen pen testers doing it too. And so we don't need, there's some savings there. But the weird thing is that because nobody actually builds these expected, has a good picture of what's expected or what they're actually getting across all these, is that we end up with this. We don't have the framework of what's expected and what's actual. We just get this picture of like, well, I have some ideas about what I think ought to be there and some test results. And so basically people just read the PDF file and they're like, well, I guess we better fix that stuff. But it's not organized in an interesting way. So I wanted to suggest a way of getting organized about that. Starting with what you mentioned, business concerns, right? At the top. And at the bottom are, I'm going to say, sensors. And what we need is to get a line of sight between those things. So the way I break it down, and I wrote about this in, if you go to ruggedsoftware.org, there's some documents there that expound on this idea ad nauseum. But the idea here is, we've got a data protection requirement at the top. And our CIOs and CEOs can understand that requirement. We've got to protect data. Well, what does that mean? We've got to break that down into some what I call defense strategies. And so, maybe we minimize the data we collect. That's part of the strategy. Maybe we do role-based access control. Maybe we're going to encrypt the data in storage and transit, and then we're going to do some logging and intrusion detection. Notice that this is a defense strategy with some defense in depth associated with it, right? It's not just one control. There's several layers of control. Then for the encryption one, and I just broke down that piece of it, you can see like, okay, well, we're going to do full disk encryption with TrueCrypt, and now we're seeing the actual defenses. Like, we're going to use TrueCrypt for that. And we're going to do programmatic encryption with the ASAPI library. And we're going to do TLS everywhere, and we're going to manage the keys with Venafi. Okay, great. Now, if we really want to get assurance, we need sensors to verify those things. And so for programmatic encryption with ASAPI, we can run dependency check to verify that the libraries are present and up to date. We can check that the encryption is correct with JUnit tests, and we can verify that ASAPI is being used properly with some sort of custom test that checks our code to verify everywhere we've got certain APIs. We want to make sure we encrypt the data that's going into them. So we can do this. It's a little bit of work, and I think probably most organizations are not going to be able to get their head around this all at once. I actually think you probably got to build up from the bottom. Start with the things you know are really critical today. Build some sensors and start gathering data and put together this picture over time. That's an agile way to build out this structure. And now, instead of just doing this, I was going to say BS, instead of doing this, this sort of ephemeral pen test where you generate some results, send to the team, and then it's gone. I have a CISO friend who's got a bookshelf behind his door filled from bottom to top with pen test reports that he's bought over the last 10 years. There's probably $50 million of work in that bookshelf, and it's not doing anybody a damn bit of good because it didn't grow. I had this law school professor, he goes, the law is accretional. And what he meant was that you start with a statute, but then the case law builds on top of that to interpret the law and apply it. And it's the same with security. You build up over time. Right now, the way we're doing it, we're not building crap. And that's a problem. So we can build this with sensors that run continuously. Now we can actually advance the state of the game. So when I zoom out from this picture at an organization that's doing this, here's what it looks like to me. Got some security-focused people or stakeholders in security that are focused on identifying new threats, business priorities, they're monitoring, and they're watching for new stuff. They translate rules into that expected model, right? They're gonna say, hey, we gotta add TLS, or we gotta add library update protection, or whatever they decide is like the next threat. I don't know what it's gonna be tomorrow. Maybe OWASP, maybe somebody releases a vulnerability here at this conference, and tomorrow it's gonna be huge news for everybody. Well, how fast can they get all of their applications through and verified in this process? Am I doing on time? Okay. So let's say they make this expected thing. They can create some new rule. They say, hey, I want data on whatever it is. Developers can implement that requirement to build a new sensor. The security people don't have to build that sensor. The developers can build it. That's actually really leveraging our expertise the right way. And then deploy that out over the application portfolio. In a matter of hours or days, you can have great data across your whole application portfolio. Data coming back in to these people that they can monitor and figure out, hey, what's going on in our enterprise? So imagine someone discovers another expression language injection problem in Spring, right? That could easily happen. And most organizations now, in order to figure that problem out, they're going to have to either do some commando raid with, like a whole bunch of people going to every project across the company to figure it out, or they're going to have to just wait several years for all the applications to get through their reviews. That's way too long. They need to figure that out very quickly. So with this system, you could deploy that sensor, get data back, and in a matter of hours or days, you'd know across your whole organization which projects are using that vulnerable library and which ones need to get a call to go fix it. That's a major shift in the way that we're doing application security to continuous and real time. So I think this changes the job of these folks a little bit. Like hopefully they get out of the business of testing for the next cross-site scripting flaw. I mean, I've found thousands of cross-site scripting flaws in my career. And I don't want to find any more. I don't care. I'm done with it. It was really cool, like the first 1,000. But after that, it's annoying. And so I want to automate that, deploy it, and get great feedback back across my portfolio. So the job changes a little bit. This is more strategic, more forward-thinking, more architecture level in a lot of cases. And I think, working with development a lot more closely. So how do you start? Well, fortunately, I don't think it's that hard. Hopefully, I've laid the groundwork for this. You can do this yourself today. You can go choose something that you want to verify and figure out a sensor that you can use to detect it. Build it locally and get it working on an app you're running locally, and then find a place to deploy it. Work with your development teams. Maybe you can talk them into deploying it in dev, or maybe you can talk it into putting it on a CI server so that it runs as part of the nightly build. Put a Maven task around it or something and get it deployed, gather that data, and then let it run for a little while. Get the results from that and build an Excel spreadsheet that shows, hey, look, here's some cool data. And go make a change in your organization. Get that vulnerability stamped out because people probably didn't know it was there. And then repeat that over and over until you realize, like, hey, we're going to need something a little better than my file system and Excel. It's going to be so valuable to your organization that you want to invest in building out a real data warehouse and making real business intelligence kind of decisions on this data. So I think this is the path towards advancing the state of the art in application security. I think right now we've been stuck in an era of AppSec compliance. we're really, we're not getting much past this sort of, if you get a chance, there's a great talk by, oh my God, I'm blanking on the name. David Rice from OWASP a couple years ago. He does a great talk about comparing application security to the problems of pollution over history. It's on YouTube, and it's easily one of the best talks that there is in application security. And he points out that, we're really doing end-of-pipe regulation here, and we need to move forward. I think we could, through sensors, we can move forward to an era of AppSec monitoring, where we can actually monitor our application portfolios and gather great data and start to build the visibility that we need in order to do things strategically. Right now, we can't do things strategically because we've got no visibility. So we got to do this to get the visibility. Then we can start thinking strategically, eventually optimizing, and hopefully someday we'll achieve David Rice's vision of what he calls blue, which is when we're doing application security, not because we have to, but because it makes total business sense and in fact drives top line revenue, not just, not even just bottom line revenue. So I wanted to finish with one thought, is that if our model is just to do what everyone else is doing, we'll never improve by definition, right? We have to think outside the box, and we've got a long way to go. I think we're really failing at application security, and I think OWASP is the right organization to drive this change. So I need your help. I'm going to start writing about this a lot and publishing about this, putting free tools out there, and I need help. So let me know if you're interested in working with me. So with that, I'm going to stop, and please stop by our booth and tweet to us if you need any information.